start. Good morning, good evening, good afternoon, ladies and gentlemen. My name is Eisaku Toda of the Minamata Convention Secretariat. Very warm welcome to the Minamata Online session, Season 2 session on focusing on the artisanal small-scale gold mining, ASGM, which is the largest source of mercury emission globally, and the sector that uses the greatest amount of mercury, and therefore one of the largest focuses of the Minamata Convention. This session is one of the science stream of Minamata Online, which is an online event, a series of online events convened by the Minamata Convention Secretariat, and we fully cooperate with the International Conference on Mercury as a Global Pollutant, ICMGP, to plan this session. I'd like to let you know that we are experiencing a bit of challenges in the connectivity and the WebEx setting and so on. So we are still waiting for the panelists to join, and we are making my colleague Shariful Islam is making his best efforts to first supporting the panelists to call in, and second, to support the attendees to participate, to at least listen to the discussion through the YouTube stream if they have any challenges in the if they have any technical challenge. So I'm not sure whether we have a Joy with us, Joylina, who is the co-chair of the ICMGP next year. Next year. So I will then go to the next slide, which is about this is a bit too small, but this is a full series of Minamata Online, and the yellow sessions are the science stream, and red sessions are the preparation for the competent parties, and in gray, as in gray, you will have another stream which is about the implementation support and a review. Next slide, please. So, a bit of housekeeping notes before we start. The participants are automatically muted, and we may be able to invite any oral questions, but basically we would like to use the Q&A box for any question and answers. We are going to have a series of presentations and then have a panel discussion or Q&A session at the end. To access the Q&A box, it may be a bit hidden, but if you look at the bottom right, there's a 3 dots, and if you click on the 3 dots, the Q&A box appears. So please send any questions using the Q&A box and send it to all panelists so that the questions are visible to the panelists, and we can pick up these questions. So this is a brief introduction to the session, and I see Joy has managed to connect, thank you for your great efforts to connect, and I will turn over to Joy to make opening remarks from the ICMGP. Joy?
Thank you. Good afternoon, everyone. Good afternoon, Esaku, and thank you very much. And also welcome from my side to the panelists, and especially on this important topic especially for the Mercury conference. And Esaku, are you going to be going to the next slide for the conference? Okay, there we go. Thank you. So very briefly from my side, this event today is linked to the International Conference on Mercury as a Global Pollutant. As you all know, the event is going to be virtual from the 24th to the 29th of July 2022. And so that is next year. And more details can be found about the event on that website. Next slide, please. Okay, and this is just the conference executive committee. Just to add that we have joined from July 2021 additional members to the committee. Next slide. So that it's more representative. And then this is probably the slide that I would like to just spend a little bit of time, not a lot, just to say that in terms of the Lifetime Achievement Award, the Mahaffey Lifetime Achievement Award, the nominations for that is still open until the 8th of October 2021. And then also nominations for a new award, the Emerging Researcher Award in Mercury as a Global Pollutant, which is then also still very much open until the 8th of October 2021. Please do go to the website on top, listed on top. So if you would like to make nominations in both of those categories. And then also still very much open is Mercury workshops. And so here I'm speaking to all the delegates on this platform today. It's the closing date is on the 8th of October as well. So it's less than a month from now. To basically, if you would like to do workshops at the conference in 2022, please submit your mini proposal. There is a format linked to this, but you can find it also at the website above. And then next slide. And then in 2024, we will have the Mercury Conference in Cape Town, South Africa, where we will then welcome all of you to South Africa in 2024. And so this is still very much work in progress. Thank you, Esaku, and over to you. Thank you.
Thank you, Joy. And if I may supplement, the first 4 sessions of the Minamata Online Science stream is dedicated to the synthesis papers, 4 synthesis papers that are being produced towards the ICMGP 2022. And the first 2 sessions were on global transport and then the Mercury in Southern Hemisphere. This is the third topic, ASGM, and the fourth topic on human health will be held next month. I'm in communication with the organizer, and it is very likely it will take place on the 19th of October. This will be announced on the web. And having said this, I would like to invite the lead author of the synthesis paper and the lead of this session, Ms. Susan Keene. Susan, floor is yours.
Thank you, Isaku, and welcome to all the participants today. As Isaku mentioned, what you'll be hearing today is a work in progress. This is part of the team that is preparing synthesis paper as well as a plenary session for the ICMGP on the topic of ASGM. So the session will start with a quick review of global emissions of mercury from ASGM but we'll look at new data that's emerging from the mercury inventories that are being developed under the national action plans pursuant to the Minamata Convention. So Ken Davis will provide us some information on that. Then we'll turn to the team from the University of Witwatersrand that are developing research on what are the alternatives to the use of mercury in small-scale gold mining. So first we'll have some technical reflections. What are some of the technical alternatives? And then we'll wrap up the session really looking at some of the social and economic considerations, this sort of enabling environment that's required for the large-scale adoption of those kinds of alternative technologies. So we're going to begin the session with Ken Davis. Ken is a policy and technical expert from the United Nations Environment Program Chemical and Health Branch. And he has been leading or working with a number of countries as a partner in developing national action plans under the Minamata Convention. So Ken is going to give us a review of what we know so far from that new data and what it's telling us about mercury emissions in the sector. So Ken, please go ahead.
Thanks, Susan. Hi, everyone. Thanks for that introduction. So, yes, it's my pleasure to present at this webinar. And in fact, yeah, there's the first slide of my presentation. So I'm going to start out by just giving a little bit of background on the national action plans and where they fit in Minamata Convention on Mercury. And then I'm going to talk about the preliminary analysis of 16 national action plans that have already been submitted to the Secretariat. So next slide, please. And we can advance it one more, please. So I know that many of you on the call have a lot of knowledge, extensive knowledge in artisanal and small-scale gold mining, but just in case anyone doesn't or just needs a little bit of getting up to speed, I just want to introduce the sector a little bit. It's a sector that's very important to the Minamata Convention on Mercury, and also very important in global development for a number of reasons. So in terms of global gold production, the ASGM sector is very significant. It produces up to 20, perhaps even more than 20% of the world's gold. It's produced from ASGM, and it's big. It employs 15 million people at least. These are estimates, actually, they're a bit old, so it could be a lot more, including 4 to 5 million women and children, and majority of these are in remote rural areas in developing countries. ASGM takes place in actually more than 80 countries. The slide says 70, but now we think it's more than 80 countries. And it's often considered informal because it occurs outside of formal permitting in many cases, or outside of the formal economy. And in terms of mercury pollution, ASGM is the largest sector for mercury releases into the environment. According to the UNEP Global Mercury Assessment, about 35% of mercury pollution is thought to come from artisanal and small-scale gold mining. Next slide, please. So then, obviously, the Minamata Convention on Mercury took this the significance of the sector as and crafted an Article 7 that is specifically dedicated to artisanal and small-scale gold mining. And the main obligation under that article in the Minamata Convention is that parties who determine that ASGM in their territory is more than insignificant have to develop and implement a national action plan for ASGM. So the party makes a determination if ASGM is more than insignificant. If it is, they have this obligation to not only develop but also implement a national action plan. And this was crafted by the negotiators in order to give countries a lot of flexibility in how they address the ASGM sector, because it's very diverse and solutions can vary, greatly from country to country. So next slide, please. And the convention gave further guidance to the parties on what kind of content needs to be in the National Action Plan. In Annex C of the Minamata Convention, there are a list of required elements of the National Action Plan. And these are strategies to eliminate the worst practices and promote mercury-free methods. Worst practices we'll take a look at a little bit later in the presentation, so I won't name those. Steps to facilitate formalization and regulation, baseline estimates of the quantities of mercury used and the practices employed. In fact, these baseline estimates form really the core of the data that we've extracted, and I'll present later. Strategies for managing mercury trade, for providing information to ASGM communities, public health strategy, and strategies to prevent exposure to vulnerable population. The last one here, strategies for mercury-free ASGM and market-based mechanisms, is actually recommended or optional in the National Action Plan. So next slide, please. So having introduced the requirement for the National Action Plan, let's look at where these projects are taking place. So the Global Environment Facility is funding through their role as a part of the financial mechanism of the Minamata Convention, projects to assist countries in developing their ASGM National Action Plan. Those are taking place in 41 countries to date. And you can see on the map there the countries that are either have finished their National Action Plan or are working on their National Action Plan. And the color coding is based on the implementing agency that works with the GEF to implement those projects. So actually, in terms of the regions, the continent of Africa has by far the most countries that are engaged in the National Action Plan process. Next slide. And just a quick note about some of the particular support that UNEP is providing to countries as they develop their national action plans. UNEP is implementing NAPS projects in 30 countries, and through a program that we call the Global Component, we're developing tools and methodologies to assist countries in their NAPS, help them do these NAPS in a way that's harmonized and learned and helps with lessons learned from other countries. You can find all these tools. I won't go through them all, but on the UNEP website, and we can put a link in the chat that has all the NAP resources. And in addition, we have a roster of experts. We do capacity building workshops, etc., all to assist countries in the NAP process. Next slide. Okay, so now let's look at countries that have submitted their NAPs to the Secretariat of the Minamata Convention. So we'll see those in the next section where we look at the data, but there are 16 as of a couple of days ago at least. I think it's still 16 countries that have submitted their NAPs to the Secretariat of the Minamata Convention, and those are on the website of the Minamata Convention. By the way, it's a brand new website. It's really great. If you haven't seen the new Secretariat website, you should take a look. And if you go to parties and click on national action plans, you can not only see the countries that have completed them, but actually download the NAP. Okay, next slide. Okay, so now let's look at the data analysis. So we've looked at the 16 national action plans, and we've done a preliminary analysis in particular of the existing practices and the baseline that the countries have reported in their NAP. So let's take a look at that. Next slide. Okay, so the first chart here that I want to show you is mercury use estimates. So this is obviously a big part of the baseline assessment. It's very natural to ask, well, how much mercury is used in this country for artisanal and small-scale gold mining? And that's a key part of the baseline that the NAPs contain. So in this chart here, you can see on the y-axis, there's all the countries that have completed their NAPs and submitted them to the Secretariat. And then the bars represent the mercury estimates, and the narrow bars, which are darker blue, are the estimates from the National Action Plan. So you can see, for example, Burkina Faso estimates they use there's about 78, almost between 75 and 80 tons of mercury use per year in ASGM. Many of these are presented as ranges. We've just put the average here. Of course, any estimate is going to have a lot of margin of error, just given the nature of the sector. And the other thing that you can see in this chart are estimates from the 2018 Global Mercury Assessment, which was, which is really the global collection of ASGM estimates that we frequently refer to. And you can see for many of the countries, they are significantly different than the Global Mercury Assessment estimate and the National Action Plan estimate. The Global Mercury Assessment estimates, by the way, come from partners who've worked on the assessment, Artisanal Gold Council in particular, who have compiled from the literature and from other unpublished studies their best estimates. And in general, these are a bit older than the NAPs. They are older than the NAPs, but now there's this big variation. So we can see, for example, the top 5 countries in terms of reporting mercury estimates in their NAPs, all really that those estimates greatly exceed what has been estimated in the Global Mercury Assessment. Ecuador is sort of an outlier here because its NAP estimate is much lower than was in the GMA, and the other countries can vary a little bit, plus or minus. So there's a lot of reasons why this might happen. One reason could be that things just have changed in the time period since the Global Mercury Assessment estimates, the references that those were taken from, and the NAP. There's also a phenomenon that we see a lot where when you look closely at an ASGM sector, the closer you look, the more evidence you find of mercury use, because it's hard to find mercury use. It's often hidden. So that can cause estimates to increase, even though mercury use on the ground itself hasn't increased that much. One interesting case is Madagascar, actually. Through their NAP process, they discovered a number of very mercury-intensive dredging and alluvial operations that really bumped up their mercury use estimates from what it was previously thought to be. So each of these countries has a story behind this. Of course, we don't have time to go into that. So we'll go to the next slide now. Okay, so what you see here is a plot of the estimated mercury use and the gold production estimates from national action plans. So in the NAPs, countries estimated their production of gold and the production and the use of mercury. And these, of course, weren't independent estimates. Oftentimes, the gold production estimates was used to derive a mercury use estimate. But it's so I don't want to present these as independent, but it's interesting to see the relationship between the two, as you might expect. On the big level, the more mercury use, the more gold production, the more mercury use, and that's of course what we see. The line there is just a line that represents a mercury gold ratio of 1.5 mercury to 1 unit of gold. So that's just for reference, and you can get an idea of what countries are reporting more mercury intense ASGM and less mercury intense ASGM. Next slide. Okay, so this is another interesting bit of data that we pulled from the NAPs, the estimates of the number of miners. And here we've, when the NAPs do disaggregate on the basis of gender, we've presented that here in the bar chart. Otherwise, for example, for Nigeria, they didn't disaggregate, so we just present the total number of miners, a total estimate. And so you can see here, of course, there's a huge variation from more than 500,000 estimated miners in Madagascar to only a few thousand, maybe in Lao PDR. It's also quite interesting to look at the male-female ratio. The range here is about 5% women miners to 65% women miners. And the median is about 38% women miners. So many of these countries have significant participation of women in the ASGM sector, something that we knew, but this helps us quantify that a little more. Next slide. Okay, and this is the last of these data slide graphics that I'm going to show you. This just shows the presence or absence of the worst practices as reported in the national action plans. So again, we see the countries on the y-axis, and then what we see on the x-axis are the 4 worst practices that the Minamata Convention defines: whole ore amalgamation, open air burning of mercury amalgam, burning in residential areas, and cyanide leaching of mercury-containing tailings to which the mercury has not been removed. The red, the kind of the reddish maroon color shows that the countries that are reporting that this worst practice does occur. And the green ones show where they are reporting that it doesn't occur, and the yellow ones are where there's no mention or no data. So for example, in Burkina Faso, they're not reporting whole ore amalgamation, but they do report that there's open air burning in residential areas, and cyanide and mercury use. So we can see here that the worst practices, at least as reported in the NAPs, are quite widespread. There's probably some gaps here where perhaps these it should be better defined whether or not these practices are occurring. But in general, we do see, especially for open air burning, almost all of the countries are reporting that, which is to be expected, actually. Okay, so I'm conscious of time. Let's go to the next slide, which is the closing slide. And I just have the co-authors, Malgorzata Stillo and Numelda de Soyatui, who've helped with the data compilation and analysis. I want to thank them. Again, we have the website with the resources. And I'll stop there. Thank you very much.
Great. Thank you so much, Ken. And what we'll do is, again, I want to remind people, if you have questions, please put them in the Q&A box, and we'll save questions till the end of this session. Great. So now we're going to move into a discussion about mercury-free technologies, and we will have speakers from the research team at the University of Witwatersrand in Johannesburg, South Africa. At first, we're going to talk about the research approach that was taken and is being taken, I should say, because this is a work in progress, and then also reflect on what we found so far. So first, I think I'm introducing Nellie, right? Nellie, are you going to be the first speaker? Because unfortunately, one of the speakers we had planned, Ponso Twala, was unable to join us today. And she was going to speak about the research framework, but I believe that Nellie Mutamere will take her place. And Professor Nellie Mutamere is a mineral resources governance expert, and she's the founding director and mining practice lead of Muti Consult, and she's also the director of the Mineral Resources Governance Research Group and associate professor in the School of Mining Engineering at University of Witwatersrand. So she's part of this research team I mentioned, and she's going to discuss first the framework that was used or is being used for collecting data on mercury-free technologies. And then I guess we may switch to other members of the research team to discuss the observations to date and some of the findings. So Nellie, please take it away.
Hi, everyone. Just bear with me while I share my slideshow with you. But in the meanwhile, good afternoon.
I think that the slides are available already online. Sharif is showing them.
Oh,
so if you just
sorry.
That's okay, no problem.
My bad.
No problem. You can just tell them to advance the slides when you need to.
Yeah. Okay. Good afternoon, everyone. I think I just want to start by saying, just acknowledging the support that we've received from the Natural Resources Defense Council to undertake this research. I work with a team of young researchers who are actually the lead authors of this work. Unfortunately, Ms. Ponso Twala, who is actually supposed to be leading this presentation, has had to attend to some urgent university business. So she asked me to step in for her and actually share with you the slides that she had prepared for this webinar. Next slide, please. Yeah. So in the work that we, as I said, that we're being supported by Natural Resources Defense Council, we work, there's 4 of us working in that work, doing that work. As you saw, the 4 authors, Ponso Twala, Itai Mutamere, Patience Singo, and myself. and was all supported and advised by Susan King from NRDC. So she is a co-author in all the work that we're producing, because the technical input and guidance is very much part of the work that we're actually undertaking. So the presentation is outlined is as follows: that I'll give some background, an introduction to the presentation, and then also share with you the objectives of the research work and the approach that we have used to actually carry out the research with the assessment framework, and then also the outputs that we are intending to actually share eventually in hopefully referee journals. And also we'll share with you some of the key insights coming out of the work that we've done and the approaches that we've actually used with this research. Next slide, please. So I think that this slide is really just a kind of touching on the key points around what was driving the presentation. Really, it was to the extent of the problem, whether it's known, what technology development efforts are in place, and to understand the current landscape of the ASGM and in the use of mercury in the sector, and also understand some of the challenges around the adoption of mercury-free processes. What we find is what one finds, which is also a driver of the research, was that the limited data there's limited data to provide clarity on the landscape of mercury-free technologies, and there are a lot of issues surrounding adoption and upscaling of those methods. Next slide, please. So with regards to the actual project itself and the backgrounds, what we're trying to do is to identify, what we are trying to do is to identify and assess the status of the mercury-free technologies that are being used or can be used in that small-scale gold mining sector. And it is a desktop study approach, and we leaned very, very heavily on the ASGM community of practice. I think the audience here today would have been some of the people in that community of practice that we leaned heavily on to actually guide us and lead us in the right direction in collecting the data. The idea was to assess technologies based on the technical solutions that they actually offer, and then catalog them as best as we can. Obviously, this can't be an exhaustive list, but we try to find as much as we can, and we have the data, which, as I said, later area that we will publish. We also try to assess the success and failures with regards to the uptake of the mercury-free technologies, and also made some proposals, or are making some proposals on renewed approaches to inform development and upscaling in that adoption of these technologies. Next slide, please. So with regards to the actual approach to the work, our assessment framework had two stages. The first stage was actually developing the assessment framework itself to identify areas. What we needed to do was to identify areas of information that are important in understanding the landscape of mercury-free technologies. And as I said earlier, we looked at on the community of practice to provide some guidance. From an academic perspective, we were looking at technical papers, any projects that have been produced in reports from those projects, and updates from the interventions that are either have been or are currently being implemented. We found that grey literature was a big source of information. A lot of the information that we had to look at and assess and extract and review was actually not coming from referee journals, but actually coming from grey literature as well. And what we were trying to do in this assessment framework was to find out how the technology works, what equipment it actually uses, how well it meets the criteria for mercury-free gold production, some of the technical characteristics of that technology, its potential health and safety and environmental hazards, the cost of acquiring and using this particular technology, and also trying to understand the level of accessibility. We also wanted, obviously, to know when it was developed, where it has been used, and how successful that application has. What we're also trying to extract was some of the challenges to adoption and what would actually be needed to actually enable better adoption of these technologies. Next slide, please. Then the second stage is that we actually then went into actual data collection. And as I said, we looked at several sources of information. and literature review was one of them, identifying technologies from different sources. Out of that, we were able to then narrow in and actually do targeted research after the initial scoping that we did with the community of practice. And then the framework that has those data sets or points that I indicated in the last slide, we started populating that actual framework. And then obviously once we had that data, we actually started analyzing that data. And the main outputs, as I indicated, are this catalog of the technologies, and also documenting and analyzing the challenges to the adoption. So those are the main outputs that we will have. And all along, we have had ongoing consultation with different people within the community of practice of the ASGM sector. Next slide, please. So this matrix here is just a glimpse of what we managed to touch on. As you see that it is looking at, I won't go into specific names of the different approaches, but I think what's important to actually understand is that we categorize them into three types of, or three approaches: physical metallurgy, which is your physical separation, hydrometallurgy, as well as pyrometallurgy. So in there, you will see that and this we have not we're not presenting this here, but I think patients will probably, who is the next presenter from our team, will probably touch on some of this. But basically what we were trying to do here is look at all these technologies, but they're all at different stages in terms of how far they've been developed, how well they've been tested or applied, and how well, and what information is actually available. And I think patients will also talk to, I think one, and I can mention it here now, is that with all these technologies and trying to get more information on them, we found that particularly the novel and more new ones tend to have kind of proprietarial kind of barriers for us to actually be able to actually get more information about how those technologies actually work. Obviously, we understand that people are doing this as a business sometimes, or trying to recover costs, but that we found that as a quite substantial barrier, not being able to actually understand. You have, like, what are the lixiviants being used? It would be just what you find on the website or in the write-ups is something like proprietarial reagents, which doesn't, for the purposes that we were trying to try to identify how the technologies work, we were not able to. But that wasn't for all of them, it was just for some of the technologies. Next slide, please. And as I indicated, already alluded to in the previous slide, we categorize these different technological approaches according to the three branches of metallurgy: physical metallurgy, hydrometallurgy, and pyrometallurgy. You will find that some of the things like biotechnology are actually falling in under hydrometallurgy as well. Yeah. Next slide, please. Okay, so I think the key is, I indicate the key insights in terms of this, the work that we have done is around the availability of data, and I think I've already alluded to some of this. The limited technical details and coverage is available from the papers and the research that we've looked at. The literature tended to be more available or more abundant with mature technologies. Records of labs that are testing and piloting, but with some of the technologies, one doesn't see actual commercial application or demonstration. Patents, we noted those, and as I indicated, the evidence of commercialization, we couldn't find any. Some of the submissions were quite high level in terms of the evidence, so one couldn't actually dig and get more understanding of the actual technology. Some of the field reports, which would have allowed us to actually see how well these technologies actually work, were not always available for a lot of the technologies. And in any follow-up research that we try to undertake, sometimes we actually just came across a barrier that we couldn't actually breach. And I think that there's a lot of technologies that are still being tested, but a lot of it is actually still incomplete and still at a trial stage. Low uptake of the non-technical challenges of adoption is something that we also encountered in the research. Next slide, please. I think that was the last slide actually. So thank you very much. And yeah, it was my pleasure to present on behalf of Ponso and the rest of our team. Thank you.
Great, thanks, Nelly. And again, pardon me, for any questions can go in the Q&A. We will collect them and have a discussion at the end of the session. I think that Patience Singo will be the next presenter, and Patience will be discussing some of the observations to date about the some of the practical barriers and practical issues when considering the adoption of these mercury-free technologies. So first, I want to confirm that Patience is there. I can see him, but can you unmute yourself, Patience, and make sure I can hear you? Patience, you're on mute. So can you unmute yourself, please? I apologize to the participants. We've been having some challenges
Susan, sorry
with
to
connectivity.
interject. I'm just trying to see if I can ask him to unmute on his WhatsApp.
Yes, thank you.
Okay.
I apologize to the participants. While we're waiting just for the technical challenge here to be overcome, I do want to mention, as Nelly said during her presentation, that a lot of the information that she described came from the community of practice. And because a lot of the information is not documented in the formal peer-reviewed literature. So for those who are on this call who may have additional information, who have interesting technical reports or field experience on the adoption of mercury-free technologies. As I said, this is a work in progress. So the team is, of course, quite open to hear your additional information, your views on the and your experiences with adopting these technologies. So just waiting one moment. Thank you for your patience. Nelly, I'm wondering if maybe while Patience is sorting his his connectivity issues, maybe either you or Ty might begin the next part of the presentation. Would that be acceptable?
Yes, sure. Yes, sure. Yeah.
Great. Just so that we can keep things moving, and then
Absolutely.
I'll keep an eye to see if Patience joins again, and then I can let you know, and then maybe he can take over midway.
Right.
Thanks for jumping in.
Yes, sure. Okay, all right. Yes, I didn't know I was going to be the star of the show. So I think that, I hope Patience is able to join us shortly. But I think the part of the presentation of our work that he was going to present was with regards to adoption of mercury-free gold processing technologies in the ASGM sector. And as I said, so Patience is one of the younger persons in our team. He is leading this particular output with myself and Consolate Waba, Itamit Mary, and Susan Kim as the co-authors in this particular output. Next slide, please. So the outline of the presentation follows as such. So the introduction to the global efforts on mercury reduction and elimination, then a classification by technology with regards to whether they're traditional or emerging technologies. And also the presentation will touch on success and failures around adoption, and also move on to look at technology performance, as well as trying to rethink how the ASGM mercury-free approaches with respect to adoption could actually be changed or done, and then some of the lessons learned from that we picked up from our research work. Next slide, please. So the global efforts on mercury reduction and elimination, I think what we were trying to indicate here is that there's been a lot of work since the 1990s exploring solutions from retorts to actual processes that actually do not use mercury. The Global Mercury Project stands out as one of the big initiatives around this, but there are many several bilateral projects on, I think, on the three main continents where ASGM is to be found. I think it's mostly Africa, Latin America, and Asia. There's an increase in the academic outputs on the subject of mercury-free gold extraction and reduction and elimination. Also, the private sector has become quite involved, particularly with regards to equipment providers. But I think for most of you that are in the audience will also, I think, recognize the fact that the private sector is also coming in as actors in the other parts of the ASGM value chain. So we're talking about producing or providing a ready market for ASGM, for gold produced by ASGM. You see private sector is quite active there, but from an equipment perspective, there's also quite a lot of private sector involvement. The Global Environmental Facility, obviously with its support to the Minamata Convention, is I think perhaps the headliner in all this work. Obviously, with a lot of this work, like in any other sector or field, there are some successes and there are some failures. However, what we find is that the evidence to actually document the success and failures tends to be limited. Next slide, please. So in looking at and in carrying out our research, one of the things that we were trying to understand is that what does deliver on mercury-free gold? What are the things that are important to have in place, or the criteria that will kind of help us to actually build more on the production of gold without the use of mercury from a technological perspective. The first is that it's important to understand the geology, and there we more like actually referring to the mineralogy of the ores and the process. So the importance is that the mineralogy must be appropriate or well matched with the technology so that you have the right solution for the right problem. Equipment and circuit processes. So one needs to understand that it's not just about equipment, it's also about the whole process flow. Because as you will find that one equipment by itself does not produce gold. So it's really important to actually look at the whole process flow and understanding that it is the combination of different equipment in that process flow, in the optimal design of that, and its efficiency and ease of operation that's actually important to deliver mercury-free gold. Competition with amalgamation. I think this is one thing that I think all of you at the community of practice actually acknowledge that, and we did get a lot of feedback and information around this, is that unless amalgamation, the alternative technology can actually compete with amalgamation, it will be very difficult to actually, for people to actually adopt those technologies. So in terms of cost, in terms of time, in terms of simplicity for adoption, and obviously the health and environment, which we desire as environmental practitioners, as people that are kind of looking at this from a strategic perspective, people that don't have to feed their families with the gold. For them, it's a secondary thing. So the competitiveness has to really be something that is important for the bottom line of those ASGM operators. Capacity to utilize those technologies is a big challenge. That there may be some technologies that are fantastic, that are very efficient, but unless we are actually able to support the capacity building of the ASGM operators and practitioners to actually utilize this equipment and operate it and maintain it, is something that we often overlook. Then the dream of mercury-free gold extraction kind of goes more into the sense, moves away in terms of attainability. In terms of the decisions of the actual miners, having a clean concentrate, the miner decides either to amalgamate or not to amalgamate. So it's particularly when you look at some of this processing, and particularly when you're looking at free milling ore, one actually, apart from those that actually are doing or amalgamation, but for those that actually do pre-concentration, it's about producing once that clean concentrate is produced, how does the miner decide, and how can you influence them deciding to go the other way rather than to actually amalgamate with mercury. Next slide, please. So what we also try to do to understand the issues around adoption was to look at the technologies in terms of two categories. The traditional technologies as well as emerging technologies. So the traditional technologies are those ones that are tested and tried, commercialized, and to the mainstream, particularly with the large mining sector or the industrial mining sector. These have tended to then be downscaled over the years for use by the ASGM sector, and were replicated in different ways or different models. Examples of this would be your sluices, your centrifuges, your shaking tables of different types, the lixiviants like your cyanide, and also direct smelting. Wide application is found in these traditional technologies in the ASGM sector, and the degree of success as mercury-free is actually quite low. The emerging technologies, there's varying commercialization in terms of the mainstream industry. Some are not yet even tried. There's still some are still concepts on paper. Some are laboratory stage. Some are maybe pilot stage or a few field trials here and there. But maybe not all of them have been actually commercialized. Collaborative approaches using traditional technologies are being taken forward. Something happened to the presentation. Okay. Hi, Susan.
I'm sorry. So Sharif, we've lost the presentation. I don't know if you can share it again. Sorry.
No problem.
Please go ahead.
Okay, all right. I think, okay. Next. And next, oh yeah. This is this one. Yeah. So I was talking about the emerging technologies, and I was mentioning the fact that collaborative approaches are being used, and then also most of the technologies are new to the ASGM sector, with limited trials and adaptation to the ASGM conditions are limited. The information on whether they are efficient or successful in their success is very limited. Examples of some of these technologies include elytriation, thiosulfate, the use of amino acids, agglomeration with coal and oil, and then the cassava method is one very different and interesting technology, where the idea there is that the cyano complexes within the cassava plant can actually be used to dissolve the gold and make it available for precipitation. Next slide, please. On this slide, I think it's just more a visual illustration of the different of the traditional versus the emerging technologies. On the left-hand side, you have your shaking tables, you have a sluice box, you have a cyanide vat leaching, and then on the other hand, you have the coal oil gold agglomeration, just to demonstrate the kind of differences between the traditional and the emerging technologies. Next slide, please. As far as the traditional circuits are concerned, I think the points to make here is that you've got gravity circuits that include sluices, concentrators, and shaking tables, and then you move on to direct smelting. And whether you can do that is a function of whether you actually have designed a good process flow for the gravity circuit. There's problems with recovery, but it can work well with high-grade free milling ores. And there's cyanide leaching, either of gravity tailings, which is used in a lot of places that are reprocessing tailings, or direct leaching of runoff mine milled ore. And then you have you can get very good recoveries, but it is time intensive and also requires good management and technical skills and capacity, of course, because the cyanide is a highly toxic chemical, so good management is very important. In terms of technical skills, as you know, that cyanide consumption is a big problem unless you when you have particular types of ore. So it's understanding that this type of ore might actually not be optimal for this would be problematic. Next slide, please. With regards to success and failures, so the successes is that there are proven technologies. There are technologies that have been adopted to this in the sector and scaled up. Recoveries and economic benefits demonstrated, and these technologies actually show that they have better economic benefits when compared to amalgamation. And expertise has been developed to operate at the ASGM scale, and miners have actually found ways of replicating these solutions. On the failure side, one finds that there's a mismatch in the circuits, where there's an assumption that one size fits all, and obviously one then encounters problems from engineer's perspective. Then you also have interventions where you have a fix and go, which are not integrated into the local ASGM in terms of the cultural, social, and economic and technical context. This is a lot of, or some, I should say, donor-driven interventions often fall foul of this. Sometimes the equipment is not properly optimized. I think we have all come across in our different ventures, ASGM white elephant plants, which have just been set up, and the equipment has not been optimized for the local ores, and no testing has actually been, proper testing has been done. And a lot of this, or some of this may be driven by the fact that the miner who actually understands their material, because there's an assumption that because they're an artisanal miner, they don't take our training, they're not consulted as much as they should, and their participation in how this technology is actually then in the equipment and the process flows or the plants are set up does not involve their input to the detriment of the success of the implementation. The recoveries of gold and the economic benefits are not convincing in some of these technologies. And again, limited capacity of the ASGM operators or practitioners to operate the proposed setups often then leads to failure. What one often finds is also that there are out there entrenched business models that are driven by not just the actual processing of the material, but by people that have their own business imperatives to push mercury into the industry. So it's often difficult to actually try and counter that. And this also is applicable to people that are actually operating the leach plants. Failures are not known in terms of actually understanding, like what was the cause of the failure and what can be done so that we can actually then learn from those mistakes instead of keep repeating them. Next slide, please. With regards to the emerging approaches, there's collaborative approaches. Yes, sure. Patience, you can go ahead. Yes.
Thank you so much. Apologies, everyone. It's been a struggle. Thank you. Okay, yeah. So I'll continue from where Nelly left. I hope we'll maintain the flow. Yeah. So as she elaborated on the traditional technologies and what we so-called emerging approaches and technologies. So within the, okay, let me try to go off video in case my internet. Okay, anyway, I'll continue. Yeah, so within the emerging approaches and technologies, so that's why you note that we've used the word approaches and technologies. It's not all technologies. Some of this is approaches to try and find ways to deal with the mercury problem in SGM. So there are two branches. So one is that of collaborative approaches, where ASM and LSM and other private sector actors collaborate, for example, with miners, selling ore to processing centers. Miners get their ore assayed. An assay value is assigned to the bag of ore, and at the end of the process, then the miner is based on that. We also have instances where after gravity concentration, the tails are then sold to a leaching plant. So these are some of the collaborative approaches that have been piloted and tried, and have been seen to work to eliminate mercury use in SGM. And on the technology front, there's a continuation of technologies from the traditional technologies, for example, in terms of lixiviants, the use of thiosulfide, amino acids as a leaching agent, and then elutriation, coal oil agglomeration, flotation. And of course, recently, I think Professor Marcelo published a paper on cassava leaching as well. So a lot of these are technologies that are emerging, especially in the ASM sector. Their use is not widely common, but there are some trials that are ongoing. Okay, next slide. And then looking at these, the emerging technologies, when one looks at the successes and challenges, we have got a list there from what we found out during the research. For example, the collaborative approach. For example, in an example in Ecuador, the miners were able to increase their income from 40 to 60% in terms of gold content, because they were now being paid according to the true value, of the gold content, rather than based on what they could only recover by gravity concentration, which was about 40%. So now that facilitated an increase in terms of their recovery and in gold content. But obviously, the other challenges with this is that it's slower. One needs to wait for the assaying, and then the whole end of the process and all that. Whereas if a miner was to use amalgamation, the results are almost kind of, I would like to say instant, but the results are immediate, so to speak. And then there's also the trust issue. The trust about lab. We had an example where a miner was debating because the assay value was saying, say, 5.6 grams, but then the miner says, but my assay is about 5 grams, and that creates a lot of problem. In terms of trust. Then with the thiosulfides, I think the tests are positive. The recoveries are above 90%. Of course, it depends on the ore type. It's still undergoing testing. Coal oil agglomeration, also the recovery is about 90%. It's also still undergoing trial testing. And I should mention that AGC has been leading in this, and they still are doing trials in the field. The same way with amino acid leaching as well. AGC has been able to achieve about 85% recoveries. Of course, it depends whether the ore is oxide or sulfides. Of course, in terms of applicability, the question is around cost. The replicability of these solutions, how easy and how simple can they be adapted to the use by miners. Then concentration and direct smelting. I know when one talks of direct smelting, there's always the debate that direct smelting is not a method. It's not a mercury-free method, of which I do agree, but it's actually a result of a good concentration process. Because when one has concentrated, either using a centrifuge or using a shaking table, I think it takes a split second for a miner to decide, do I go direct smelting or do I just pour mercury and amalgamate the whole thing. Yeah. But with the miners' intent to go mercury free, they can choose to go direct smelting without applying mercury. And look, it does work, but the biggest challenge with direct smelting plus concentration is that plus gravity concentration is that it works well with high grade ores. Therefore, in terms of recovery, the total recovery of the deposit becomes poor. It takes a lot of time, and I've heard from a number of miners that have been trying this method that when it compares to them using mercury, it's very slow. So these are some of the challenges that we have. The methods do work, but we have these challenges of time, cost, applicability, and all that. And then gravity concentration. This speaks to to the traditional approaches, and then the shaker tables and the centrifuges. Again, is the same thing. One can get a good concentrate, maybe 50, at most 70%, but usually it's in the region, it's in the range of say 30, 40, 50%. But then also it depends on the ore type. Is it coarse gold? Is it fine gold? It also depends on the quality of equipment and the process optimization. One thing that I've seen, or we have seen in this research, is that when somebody says, I've got a centrifuge, somebody else also thinks that with a centrifuge, you can go, one can achieve mercury free, which is not necessarily the case, because is it well optimized? Is it properly manufactured and all that? So there's a lot of stuff going out there in the name of mercury free, but yet in terms of optimization, these things have failed the miners. Because at the end of the day, the miner is looking at maximum recovery. So they look at what they get with the mercury-free approaches and what they're able to get through amalgamation, and then they make that comparison against the effort that they put, against the time and all that. Okay, the next slide, please. Right now, I think based on these studies and what we've been able to understand from projects that are being implemented, the challenges that have been discussed, I think there needs to be a rethink on ASGM, mercury-free approaches, and what can we learn from the past. I think the first thing on the rethink is, there's very limited sharing of data, whether success or failures. I tell you, we've been looking, we've been searching, but there's not a lot of information. So even the guys that have failed have stayed with their failure. And the chances that these failures are being repeated are very, very high, because there's very limited sharing of information. Whether you talk of bilaterals, all this information is collecting dust, somewhere in the shelves, and yeah. But we are not pushing it out there so that we can learn from the mistakes. Yeah, and then so
Patience,
there's
Patience, can you wrap up in a minute, because we...
okay, that's fine, that's okay. And then there's the ASGM realities, this bottom-up approach, the processes that take into consideration ASM capacities. I think there's need for the consideration of what the miners think and say about these technologies. And then another factor is mineralogy informs mineral processing. So it starts with understanding of the geology, the understanding of the mineralogy, then that leads into the design of the circuit. And then, of course, active participation of miners in the test work, which links to the other point that I spoke about. But one thing that we've seen is that there's quite a number of equipment graveyards. You find that even a high-tech equipment like a shaker table could still be found in an equipment graveyard, because it has not there's not been adequate consultation with the miners. And of course, the last bit is to target the right group, for piloting, understanding the capacity of equipment and the capacity of the miners. Okay, the next slide, please. Hello? Yeah, okay. So that's it, and thank you very much.
Yeah, thank you, Patience, and thanks for jumping in. And I really do like that review of you know, what we need to move forward and how to rethink the process a little. So again, we'll hopefully we will have questions for the end. I apologize that we've had some technical problems that delayed the start of our webinar, so I hope everyone can hang on for a few minutes after the scheduled time for some Q&A. But meanwhile, we have one last extremely interesting presentation from Anne Nakafiro. Anne is with the Uganda, sorry. Anne is the Senior District Support Officer and also the National Focal Point for the Minamata Convention on Mercury for the Uganda National Environmental Management Authority. And Anne is going to speak about the social and further social and economic challenges and what is sort of the enabling environment that's necessary for the adoption of mercury-free technologies. Patients started to touch on it, a lot of technical and economic issues, but Anne is going to speak, you know, more broadly about some of the social and economic considerations. So Anne, hopefully we can hear you. If you can unmute yourself and begin your presentation, please go ahead.
Yes, greetings everyone. I've already been introduced. What I'll say before I go into the presentation is that the social and economic consideration for the adoption of non-mercury-free processing technologies is anchored on justifying the cost-benefit analysis of the mercury-free technologies and also influencing the miners' mindset, in addition to ensuring that there is enabling policy and legal framework for the adoption of these technologies. Next, please. So those will be the presentation, those are the presentation highlights, social and economic consideration for the adoption of mercury-free technologies. Next, please. So under social considerations, we have low miner education levels. Having low miner education levels influences their ability to supervise, operate, and maintain equipment for mercury-free technologies. In addition, it affects record keeping. Hence, it's difficult to envisage the costs and benefits of mercury-free technologies. So we are recommending that, among others, the curriculum for public vocational institutions is updated to cover gold processing and fabrication of tools, to develop popularized handbooks. For instance, that picture that is showing in the slide is written in English. It's about the symptoms of mercury, but very few miners will be able to read it and also to really understand it. So we need to popularize our materials into the local languages, and where need be, carry out, demonstrations, dramas, and give a direction where we want our miners to. But also having miner exchange visits and training of local masons and fabricators is key. Next, please. Yes, so we also need to demonstrate the gold yield versus the processor's wages, especially. If you look at the figures that are on that slide, you realize that a processor will earn according to the gold that will be recovered. So if we can demonstrate to them that the alternative technologies will yield much more gold and therefore their wages will be increased, then they are likely to adopt the technologies. Next, please. Yes. The other consideration is the influence of weather on gold processing methods. You realize that processing of gold with mercury is not that much affected by weather, as you can see in the photograph. The photograph below shows it was a rainy day, but someone went on processing their gold, of course, with mercury, as opposed to the mercury-free technologies where one has to crush the ore and ensure that it dries very well. So miners find challenges using the alternative methods that are mercury-free during the rainy seasons, because the ore has to be very dry before you subject it to gravitational methods, among others. So there is need to promote mercury-free technologies that are all weather friendly. Next, please. Yeah, there is a concern of gender inequality under social consideration. Women ASGM site leadership is quite minimal, as you can see in the photographs also. You find probably one female miner to 10 miners on a committee. But in addition to this, there are also minority groups that exist that undertake mining, and yet they are also less economically empowered, and therefore would need to be supported to undertake mercury-free technologies. The photo up is a community member from northeastern Uganda, that's Karamoja region. You can see that he travels distances to come and pan their gold. So you wouldn't expect this person to take up easily the mercury-free technologies that would require even more water. Moreover, they are living in water scarce areas. And therefore, the recommendation also is to enhance the women SGM site leadership such that their technological challenges are addressed as they come. Otherwise, we end up seeing white elephants of demonstrations that were put in place in different areas, but which were not adopted as a result of the challenges that women face while using them. Next, please. Yeah, there are also buying habits that we need to take into consideration. Remember that mercury is physically supplied by middlemen to miners at the site, and hence they do not have to travel long distances to buy the mercury. So they don't waste a lot of time. Unlike probably the gravitation methods where finally borax is used for purification, a miner has to travel to the city center to buy borax and even other inputs, which is cumbersome in terms of travel costs, the time, yes, and also the experience or expertise in identifying these inputs. And here, what we are saying is that can we entice the landlords, the landowners, the middlemen to supply these inputs to the ASGM sites, just like they've been bringing mercury. In the photos, you can see already there is a lady who is selling, I think she's a healthcare giver. So that sector is already reaching out to the miners, but the suppliers of the alternative inputs are not yet at these SGM sites. So this is something that needs to be taken into consideration. Next, please. Availability of social services is another social consideration, though it's also cross-cutting in terms of economics. There is limited availability of social services, for instance, electricity, water supply at the camp, and yet alternative technologies require a lot of energy and water. You can see it in the picture above. It was also taken in the Karamoja region, northeast Uganda. You find mothers going to the riverbanks, to the rivers themselves to wash clothes. So they sit from morning until when the clothes dry and they travel back, which implies that these are long distances from home. They cannot afford to go and hang the clothes and go back to attend the house chores. But the same rivers are also serving as the sources of water for gravitational activities of gold extraction. Now, one aspect, if you're bringing in an alternative method that would require water, are you going to place it at the river bank, away from the camp? Isn't it going to be a competitor of water, of water sources in that area? So these are some of the things that we need to take into consideration. If you're going to promote these technologies in already water scarce areas, and where they are economically disempowered persons, what is going to happen? So the recommendation here is to extend microfinance services, public utilities to remote areas. This may reduce the gold production costs with mercury-free method. Next, please. Now, it takes us to the economic consideration for the adoption of non-mercury processing technologies by miners. And here, we've considered public awareness, both at national, local, and community levels. At the national level, it will yield policy changes to facilitate the adoption of these technologies. At the community level, it will raise awareness. At the local level, it will improve on monitoring and extension services to be offered to the miners who have taken on new technologies. Now, majority of the gold processors do not own land or mine pits on which gold is mined. They are hired as workers. So the adoption of mercury-free technologies may majorly be dependent on the landowners or pit owners who usually do not have time to attend these awareness meetings. So we are proposing that there is need to strategically engage the landowners, community elders, local council leaders, especially in those areas where these leaders are the ones that oversee the activities. We need to engage them and bring them on board, given that they will not attend to the common methods of public awareness like face-to-face or meetings. We need to be innovative in bringing them on board and also create public awareness along the value chain, for instance, with gold dealers, the jewelry shops, refineries, among others. Next, please. Yes, so there's limited capital for investing. There are high operational costs and maintenance costs along the gold processing chain with mercury-free technologies. In the picture is a centrifuge that was donated to one of the artisanal mining sites in a specific district in Uganda. Now, when you compare that technology, the centrifuge, with the lower picture where people are using basins, they find it easier to use the small basins compared to the other machine, which is not only expensive, but difficult to maintain. And they don't have options of, a machine that relates to the ore grade. And therefore, we are recommending that there is need to develop mercury-free technologies that require limited operational costs in terms of water, energy consumption, and even the maintenance cost should be low. But also, again, we need to engage ASGM and enhance their collaboration with microfinance institutions to be able to access credits. Next, please.
And I see you have a bit of number of slides more, so can you accelerate a little bit?
Okay, yes, thank you. Yes, that is gold marketing, and here we are saying that the cost of mercury-free gold and that is produced with mercury, they cost the same. So we are recommending that can there be an alliance, regional alliances that set prices for mercury-free gold. This can be through development of mobile applications or for cell phones to enhance information sharing. Next, please. The gold processing time is quite long. The pictures are indicating a gravitational method where borax was eventually used to remove the impurities from gold. These processes are usually lengthy. They cost a long time, and yet women especially, and even the male miners, have to attend to other needs. Next, please. The issue of land security is also key. Miners usually experience erosion from land and they don't have security of tenure, so they would want to invest in equipment that is easily movable, like the basins you see, as opposed to the mercury-free technologies that are usually permanent. So can we think of the movable mercury-free technology such that in an event of eviction, they are able to go with their equipment, but also facilitate them to gain land security? Next, please. The ball mill capacities sometimes do not favor the quantities of ore that are produced by women. So we are saying, can we have various sizes of ball mills to facilitate the women who can only bring in a little to process their ore? Next, please. Yes, and here we are saying that a particular technology may not suit all ore sources. We have alluvial and hard rock. So we are recommending that the technologies should be tailored to the source of ore. Next, please. Next, please. Next, please. I have spoken about this. Yes. So we need to hold the gold dealers and refineries accountable in terms of using safe gold processing methods. And the picture shows a fair trade certificate for one of the miner associations that was facilitated by the civil society organization. Next, please. So in conclusion, There is no single mercury-free gold processing technology that suits all needs. However, continuous research into improving mercury-free technologies and tailoring them to our grade quantities, our sources, users, scale of operation is needed. Social and economic consideration for the adoption of these technologies is key. However, policy and institutional consideration are critical too. Therefore, overlooking these considerations may affect the adoption and sustainability of mercury-free technologies. Next, please. Thank you very much for listening.
And thank you so much for such a really insightful and interesting presentation. It's really quite a lot to think about. I know that we only officially have 5 more minutes. Unfortunately, we didn't have a lot of time to leave for questions. Sorry for the technical difficulties that ate into our presentation time. But nonetheless, I do see one interesting question that from Marcelo Vega that I want to pass along to the panelists. And Marcelo notes that I think it was Patience who talked about, or maybe it was Nelly who talked about a model of, it's not a mercury-free model, but per se, but it's rather a shift in business practice where miners bring ore to a processing center and sell it or process it there, and then actually it's the processing center that does the processing and pays the miner for the gold. Marcelo notes that in many circumstances that relationship can be exploitative, that the miners in some processing centers, the miners actually come and work the ore and still use amalgamation, and then the processing centers retain the tailings for profit. And that's shifting. There's others ore selling in lots of countries: Colombia, Peru, Costa Rica, Nicaragua. There's many others. But I think it's a really good question of, those kinds of relationships. And Nelly, you mentioned it in your presentation of, there are people with vested interests in the continued use of mercury. So anyone on the panel, if you want to unmute yourself and comment on, what do you think, if anything, can be done to, avoid that situation of, what are we going to do about the people who will be actively working against us as we try to, transition to a mercury-free process? What it means is, there will be some losers, some people who lose out on profit. So how do we address that question? Patience, go ahead.
Okay, thanks. Look, I think that's one particular issue that surfaces when it comes to even to gold trading and dealing, when one has to deal with illegal traders. And so how do you deal with that? So one way is to bring them on board, avoid fighting them, but perhaps start with them. Start with them. And the second thing is to try whichever model we bring in to try and create a balance of economics, because today X benefits like this, Y benefits this much, and whatever we are trying to introduce, we are inclusive of all players, and we see how this new intervention can distribute these benefits across that whole value chain.
Yeah. Great. Thank you, Patience. Any other comments from the panelists on that? Okay. I did also want to actually, I have a question for Ken, and it's really related to this issue. Ken, in the presentation, you showed that the National Action Plan for Ecuador showed a decline in mercury use, or maybe it wasn't a decline, it showed less than was reported historically in the Global Mercury Assessment. I wonder if you have any reflections on that particular situation, because that was a pretty dramatic drop, and whether you think, based on any insights you have into that NAP, whether this change in business practice of just much more what they call toll milling, much more many more miners sending their ore to a centralized processing system might be the cause of that decline. If you have any insight into that, Ken.
Hi, Susan. Yeah, I just had to figure out how to unmute here. I don't really have a good insight into the Ecuador NAP. I think this was a UNIDO implemented NAP. I don't want to put go too much on the spot, but if you want to come in and if you do have a insight into why that difference in mercury use was described. I don't think that they necessarily discussed the comparison with the global mercury assessment. I think it was just presented as this is the mercury use that they have. So I mean, the short answer is no, I don't know, but certainly that's worth looking into because the estimates differ so much. So so maybe that's something I can get back to everyone on.
Thank you. Okay, I think we have time maybe just for one more question, if anyone has any.
Susan, in the chat box we have two questions. One
Okay.
is and
Well, one question was from Kirsten, where I believe she asked the question about whether the ore type and mineralogy had been factored into the assessment, the research. And I think that question was answered during the presentation, that indeed those things were incorporated. And maybe for the first part about how was the community of practice identified, maybe Nellie could answer that question of, exactly who did you reach out to? Well, you don't have to give a full list, but generally speaking, who did you consider to be the community of practice?
Okay, it's a difficult question. I hope we did not exclude anyone who might have felt injured by us not reaching out to them. But I think the way we did, because so I'm old, right, and I know a lot of people in the sector, right. So that was the beginning. If I don't know them, no one knows them. No, so I'm kidding. But what we also did was to use some of the platforms that where people that are active in the sector. I think, Kirsten, you're probably one of the people that was responded through that channel, which was that partnership. I think it's a Yahoo group or something like that. So I think perhaps the biggest contact we made was through that particular platform, and then of course a lot of it was then snowballing from that. Yeah, I don't know if that answers your question.
Great, thanks. Yeah, thank you for the plug, Nellie, for the Global Mercury Partnership, for our ASGM partnership area. That reaching out to that through the listserv of that partnership area did result in a lot of information. I think we're going to have to wrap up there. So Asako, I'll turn it back over to you with the thanks to all the panelists, and apologies for some of the technical problems, but I think we overcame them very well. And thanks, I know that you all worked really hard on making these presentations, which will be available, as I understand, on the website. So Asako, back to you.
Thank you, Susan. Thank you, all the panelists, experts, and this is a wonderful session. We learned very much about the current technology and the opportunities and limitations, which is essential to for the practitioners, for policymakers to address the ASGM problem, and we very much look forward to the outcome of the research, so that we can make as much as possible the technical information, technological information to available to the governments and practitioners. So I very much congratulate you on progress so far. I would like to turn to Joy as a co-organizer of this session. Joy, if you have any closing remark.
Thank you, Eisaku, and thank you very much, Susan, also for getting together all the panelists today in the presentation, and then also all of the best with the synthesis paper. So this is, of course, towards the conference, and so Thank you once again, and I can certainly see all the work that has gone into it, and it's really exciting to see science in the mercury field. And then Isaku, just to thank you also for giving us the opportunity to partner with you on this as the conference, the Mercury Conference for 2022, and also your team, Shariful, who's really been very good in sending us all the links. Thank you once again, Isaku, and over to you.
Thank you, Joy. So my last remark is thank you to all the attendees who participated in this event. And if you have any comments or questions, you can send it to the secretariat so that we will forward it to the lead authors and speakers to react. So we very much looking very much looking forward to the future of the of this study research. I say thank you to all and goodbye. Have a nice day. Have a nice evening. Thank you very much.